Hello everyone, here is today's problem. Suppose A, B, C, X, Y, Z are positive, with the sum of A, B, C equals 1 and the product of X, Y, Z equals 1. We are asked to find the minimum value of x squared over 6a plus 3 plus y squared over 6b plus 4 plus z squared over 6c plus 5. We're going to use AIME inequality and Cauchy inequality. So first we let the expression as j. Then by Cauchy, 6a plus 3 plus 6b plus 4 plus 6c plus 5 times j will be greater than or equals to x plus y plus z squared. On the left hand side, it is 6 of a plus b plus c plus 12 j. On the right hand side, it is square of sum of x, y, z. And now using AIME inequality, x plus y plus z is greater than or equals to 3, the product of x, y, z raised to the power of 1 over 3. Using the condition of the sum of ABC equals 1, so this is 6 plus 12, so it is 18j greater than or equals to, with the condition of the product of x, y, z equals 1, this is 9. And therefore j is greater than or equals to half. Equality holds if and only if x equals y equals z equals 1. For ABC, that is 6a plus 3 equals 6b plus 4 equals 6c plus 5 equals 12. Meaning that ABC equals 1 over 2, 1 over 3, 1 over 6, and x, y, z equals 1, 1, 1. And therefore, the minimum value of j is indeed equals half. This is the end of today's discussion. Hope you enjoyed it. I'll see you again next time. Bye bye.